So to sort of introduce the partnership, the Union Pacific and AutoModality teams came to visit us, DJI, in our Shenzhen headquarters in the February of this year. At that meeting, we decided we would come together and establish a three-way partnership, a strategic partnership, in order to revolutionize the way that the railroad industry has operated over the last 100 years. And since then, we've been able to make groundbreaking strides in various applications, from autonomous infrastructure inspection to critical incident reconstruction and analysis. So Ed, as an industry veteran in the railroad space and currently the leader of your operational safety team, how did your team come around to using drone technology for good?
Bill, we started our inquiry into drone use back in 2014, and by 2015 had acquired our 333 exemption with the idea that we might be able to use this to do some very sophisticated track-based inspection. We very quickly decided, though, that the drones, especially with the onset of the Part 107 release, would be best to be put into the hands of people that are actually doing the work. We heard Corey talk about that earlier in the presentation. That seems to be a common theme now across most of the industry. And as such, then began developing two use cases where we have people that are out doing their day-to-day work and working on things like employee safety, incident response, service restoration, where we have basically people that are doing what they've always done but are able to do it more efficiently than they were in the past. We wanted to extend that to the concept of bridge inspection in particular. Between our bridges and other major infrastructure, we have about 18,000 pieces of infrastructure out there, all of which are inspected by humans and by hand. And we wanted to extend the use of the drones to do that work. But we found out very quickly that when you put a drone that likes to be very stable in a GPS environment into one where there is no GPS, it becomes quickly a very different animal to fly. And so we had to rethink our whole strategy. We had to decide, are we going to go to a different model where we are going to employ dedicated drone pilots that we specifically train with a high degree of skill, or are we going to retain the original model that we very much believed in, said put the drones into the hands of people that are doing the work? And we elected to stay with the latter, but we then had to find a service provider, somebody that could help us develop the necessary technology so that those drones could be just as reliable in non-GPS or GPS-denied space as they were in GPS, acquired space. We spent over a year looking for that particular partner, canvassed every conference, talked to as many people as we thought we could touch within the industry, and finally at AirWorks 2016, we met Dan and his team at AutoModality. And that relationship has blossomed quite nicely, and our solution that Dan will talk about here in a little bit has come along quite nicely. Let us keep our business strategy of keeping the drones in the hands of people that are doing the work.
Fantastic, thank you for sharing. So Dan, everyone here knows that AutoModality is a true leader in autonomous solutions for drones. Can you walk us through, us in the audience, through how did your company first start up? What made you go into commercial UAVs? And finally, can you share some experiences about your work with the Union Pacific team?
Yeah, sure, Bill. AutoModality's founders have had a passion for autonomous mobile robots for decades, actually. I'm a little bit older, maybe, than I challenged up here. And when we had time to create a new venture, we wanted to take that passion, and we saw the convergence of technology that was going to allow us to actually focus on real applications. Because all the times we've tried to do this in the past, we were bogged down in soldering and making systems on a chip, and we've done a lot of hardware work. But what really came to be in the last few years is the off-the-shelf nature of the hardware platform that would allow us to actually focus on applications and behaviors. And so we started up AutoModality. The key to our whole company is autonomous. It's encapsulated in our name. And so we approach the problem space from that autonomous nature right from the very beginning. And so we tended toward problems that required that autonomous feature. And so our early customers and applications were vineyard inspection, and not high-level vineyard inspection, but actually inspecting a vineyard like a human would inspect a vineyard from a oblique angle a few feet away from the vines. A levee inspection was also something that we hired to do early. For levees, you want to look at that little channel right where the water hits the dirt, and you just can't do that from high overhead. You have to be very close up. So to fly very close up, as I think probably a lot of people out here understand, if you're trying to fly even more than 10 meters away, very close up, it's a very difficult task. An autonomous flight is really the way to get it done. So we developed that technology. We right as we were sort of coming out of stealth mode, DJI released their M100 and SDK products. So as Arnaud said earlier, that the key to us is that onboard SDK. So we put a computer on board, and we use that onboard SDK to talk to the underlying drone. And so we entered the SDK challenge, and we won that. And we ended up on stage, our first at your first AirWorks on stage at the keynote or on the main stage during the first day. And that's the time at which Ed took notice, I think, of our technology, and we took it from there.
Fantastic. So Ed, there's been a lot of talk around this Benicia Bridge project. I've seen it myself. Several of our other colleagues in the audience have seen it. Do you mind going through, what is the Benicia Bridge project, how it came about, and some of the challenges that the Union Pacific team and the AutoModality team embarked upon to solve as part of this project?
So it's an interesting beginning to a very complex problem. We had, when we approached Dan and his team, we really had this real desire, this real vision of developing fully autonomous inspection of bridges with the GPS denied problem that I talked about previously. But in order to do that, we had to pick several test bridges that we could apply Dan's technology to. And so I met with Dan, and we went over about 3 or 4 different possible bridges. And the one that was closest to the AutoModality headquarters happened to be this Benicia Bridge over the Suisun Bay in Martinez, California.
So we can actually see it on the screen right now, right?
Right, and so that bridge is over 7,000 feet long. It has it has 10 different major segments to it, including a lift span to allow bridges to go through it. It has nearly every imaginable weather concern that you can conceive, with the exception of snow, and I'm sure that will come eventually. And so Dan and I went out to the site, and we looked at it, and I said, well, Dan, here's your bridge.
Dan, and I went to the bathroom.
Yeah, and 17 months later, Dan and his team have done just a fabulous job of going through this, what is arguably one of our most complicated structures, and truly developed autonomous flight through those segments.
Right. And so Dan, to finish up with you, in your experience working at AutoModality, as well as one of the leading solution providers in the drone space, tell us about your experience with the Benicia Bridge project, as well as what advice you have for your peers out in the industry.
Yeah, I think those are, we'll start with the bridge itself. As you can see, and as Ed said, it's an imposing structure. And so the good news was that it fit very well with the way that we saw the world. And with the close-up flying that we do, we actually don't need GPS. We actually don't need RF. So if we're in indoor environments or underground environments where RF is challenged, we don't need those either. So we were able to use our feature-based localization, and if for those of you who were here last year, Ed Cook, the CTO, gave a talk on that, and using that feature-based localization on this structure, we were able to just divide it into pieces that that were achievable and work them one at a time. Now that said, this is a very large structure, so. If there's a lesson maybe to be learned or to be taught is, think about the pluses and minuses of going with the hardest bridge maybe in the inventory of your customer. There were actually, you can imagine the downsides to that, but there were actually some upsides, which is that I think we saw everything that there was to see in this problem space right up front. So that kept us from getting surprised as we worked our way along.
Right. So do you want to talk a little bit about the VR simulation we're actually seeing on the video right now?
Yeah, so so what you're seeing here is a model of the bridge, and this ties back to the talk that Ed gave last year that I mentioned, is that The challenge to our perceptive navigation technology, where we're using feature-based navigation, is that you have to have a decent model. And sort of our whole foundation of our offering is based upon that. And the deal is that if you're just flying against a random point cloud or a bunch of points, it's hard to communicate both from the customer, the asset owner, to us where they want to fly, where the challenging areas are that they want to see, and also for us to communicate back what we're seeing. So this is actually showing that quite well. We developed this VR system to encapsulate that feature-based semantic model of the bridge, and it really helped with workflow. That goes back to the stuff that Chris was saying with the workflow and focusing on workflow. It allowed Union Pacific to visualize what they were trying to do. It allowed them to give us requirements, and allowed us to actually test against it, tying into the Microsoft offering as well. We're looking forward to talking to them about getting that testing going on a structure like this. So what you can see here is a flight through, and this is, you can come see this in our booth. We actually have this system running in our booth with the goggles. But as the drone flies along this yellow path, you can point to features on the bridge and identify what they are semantically, like this is a beam, this is a whatever, and then identify the particular defect or issue that might be with that component of the bridge. So here you can see we're pointing out, pipes, structures, and then we actually go to the gusset plate and we'll select what the particular issue is here. Those get tagged and uploaded into the asset management system so that Union Pacific can do something with it.
So, and I'd like to add to that if I can too. One of the big lessons, the biggest lesson learned, at least from the Union Pacific side in all this, is we actually bifurcated our development of this project into two pieces. One using the VR. As Dan said, the VR was originally developed out of our point cloud models to design the semantic and navigation models that allowed his team to develop the flight physics necessary to go within that infrastructure. At the same time, what it did, all these identifications of the features and the defects that you're seeing popping up right now, it allowed our team to sit down with bridge inspectors who do this work and say exactly what should we see when we look at the drone flying through the structure. So the way that we identify defects, the way that those are labeled, the way that the features are understood, even the flight path that you see was all part of that side development in the VR world, which we then brought back to Dan and said, hey, can you make this work? This is what we think we want. So it's an iterative approach using VR and real-world development, and it greatly increased the speed or decreased the speed in which we developed this product.
Right. Well, thank you both for sharing. That's a very interesting project that DJI, I know we've had the pleasure of being a part of, and we'd like to see more from it as we develop this further.